All right, so you just practice four terms. If you have four terms, you can use that factor by grouping. So what we're going to look at here is what if you have three terms? Well, three terms, we're going to use that old technique that I'm sure is your favorite, the RS method. All right, I told you we're going to use the RS method a bunch. I was not lying. So if you have three terms, you're going to use the RS method. So we're going to look at a slightly new way to use it. So let's write this in our notebooks. So you have factor the expression 2p to the eighth power minus 12p to the fifth power minus 32p squared. So get that written down. Okay. Now, if you remember last class, when we were in person, I said there's something you should always check for first. And actually, with this one, if you don't do this first step, RS method's going to be kind of messed up here. So we always want to check for one thing first, and that is you always want to check, is there any simple factoring? Don't forget, oh gosh, sorry, I'm trying to write with this little tablet thing. Don't forget to check for simple factoring. Oh my goodness, my handwriting. It's terrible on this. What's happening? Um, Always check for that, simple factoring. So always look, is there something that all of these have in common that you can take out first? And in this case, there is, right? If you notice, in terms of numbers, 2 goes into 2, 12, and 32, so we can take out a 2. And we have a p to the eighth power, a p to the fifth power, and a p squared. So they all have at least p squared to give up. So we can take out 2p squared. All right, and let's see what would be left. So what would we multiply 2p squared by to get 2p to the eighth? Well, it's going to be p, right, to the, now you're probably going to be tempted to say one of two things, either the fourth power or the sixth power. And you want to remember, when we're multiplying, we add exponents. So we're going to want to do p to the sixth power, right? P squared times p to the sixth would be p to the eighth. All right, then for the next one, what do we need to multiply 2p squared by to get negative 12p to the fifth? Well, that would be negative 6p to the third. And what would we need to multiply 2p squared by to get negative 32p squared? Well, that would be negative 16. All right. And now we can do the RS method with that inside part. So we RS still means the same thing, right? R times S is still A times C. So in this case, A would be 1, C would be negative 16. So that's negative 16. R plus S still has to equal B, that thing in the middle. So in this case, negative 6. So we need two numbers that multiply to negative 16, add up to negative 6. And in this case, I believe those are going to be negative 8 and positive 2. Now we're going to use those the same way we've been using them. So we're going to keep the 1p to the 6th power as it is. We're going to keep the negative 16 as it is. We're just going to expand that middle term. Now what I'm going to do here first is going to be a mistake. I'm doing this on purpose. So I'm going to expand negative 6 using negative 8 and 2. And what a lot of people are going to do is they're going to say negative 8p plus 2p. Right? Negative 8p plus 2p. Now, if you remember, when I first showed you RS method, I said the common mistake was people forgetting that variable when they expanded the middle term. And I have the variable there. I didn't make that mistake. So what is my mistake? Well, my mistake is that we want these to combine to a p cubed, right? And I just have p's right now. Negative 8p plus 2p would just be negative 6p. In order to get them to combine to a p cubed, we need to keep those as p cubed. So whatever that middle term is, whatever that exponent is, whatever that variable is, keep it exactly as it is with the exponent. Okay, and now we go into something that hopefully you're pretty comfortable with, the cut in half, move to the factor by grouping part. So what do these two have in common? Well, they have a p cubed. What would be left? Well, that would be p cubed minus 8. On the right side, we're going to take out a positive number. In this case, we can take out a 2. So it would be p cubed minus 8. All right. Take out the common binomial, p cubed minus 8. The other one's going to be what's left, p cubed plus 2. There we go. And now people are going to be tempted to be like, I'm done. There's a few things. One, that 2p squared from the beginning, we want to make sure we bring that down. So we want to bring down that 2p squared from the start. And the others, we have to check, is anything in here one of our special cases, right? So 2p squared, nothing we can do there, right? That doesn't look like any of our special cases. P cubed minus 8, let's think, is this a difference of perfect cubes? And in this case it is, right? So let's think, what cubed minus what cubed would that become? Well, p cubed is p cubed, obviously. And then what cubed is 8? Well, that's 2. So we have our a and our b. And let's fill that in with our difference of cubes. So it's a minus b times a squared plus ab, in this case 2p, plus b squared, or 2 squared, which is 4. All right, so we factored the p cubed minus 8 using the difference of cubes. And then we have p cubed plus 2. So is that one of our special cases? Well, you might think, oh, it's tempting to say this is a sum of cubes, right? Because we have p cubed plus something. But 2 is not a perfect cube. So we can't break that down, right? There's nothing we can write as something as a whole number cubed that's going to equal 2, right? That's not going to work. So in this case, we're just going to leave that as p cubed plus 2. And this is our final answer of that thing fully factored. We factored it as much as we can. Now, again, just quick check. If we look, we started with a p to the 8th power. It was an 8th degree. So let's look. So here we have p squared. So that's 2 p's. We got a p. There's another one. A p squared. There's another 2. And a p cubed, which if we add those all up, let's see. 2 plus 1 is 3, plus 2 is 5, plus 3 is 8. Nice. So we know that at least the degree of this thing is the same as the degree we started with, and that's always a good little check to do at the end. Great. So the next slide is going to have you practice some RS method, right, with some higher degrees than just quadratics. And then there'll be one more slide with a video after that for you to take notes on, and then you're almost done. Great. See you on that next slide.